All right, so this culminative assignment number 3, we're trying to create this exponential class. So I just copied in the stuff from the reading that goes into the graph program. So this is supposed to represent, well, and you could call it f of x, but 2 times 3 raised to the x minus 4 minus 3. So if you know about transformations, it's like you have the base function 3 to the x, you got a vertical stretch of 2, you have a horizontal shift to the right of 4, and you have a vertical shift down of 3. So we want to be able to draw that function. Well, we want to create an exponential class. Exponential. Okay? And remember, we want it to extend function. Remember, we had that abstract class of function. So we have float a, float b, float h, and float k. Now, I wouldn't care if you did a, b, c, and d. The h and k are usually used for transformations where h is like the horizontal shift and k is the vertical shift. But that's fine. Okay, so I need a constructor. It'll be public exponential. It would be float a1, float b1, float h1, float k1. But basically, we want to create an exponential just like we did in graph program by giving it 4 floats. And assigning those values, h equals h1, k equals k1. Okay, assigning those values to the fields. So we have an exponential. Now the reason this one is not compiling is we didn't implement the inherited abstract method get y. So if we're calling an exponential a function, which it is, then our abstract class says, well, you should be able to implement a get y method. So, and the get y method is what takes everything off, right? It's what's going to be able to graph the exponential. We just need to be able to give it an x and get out a y for this exponential function. So that's kind of where the most important information of the class lies here, right? So it's public float get y passes an x. All right, so think about, and we have to think about what these values mean. Well, we could really do this pretty. You need to know order of operations, but really, we can return a times. This will be pow. Okay, so pow is a method in processing. Just raises one number to a power, so it'll be b as the base. The exponent would be x minus h. I guess I could do, I don't know if I need to do x plus h or minus h. Well, so we can do it either way. We just got to remember that this is actually, if h is positive, let's do it as plus, and then plus k. Okay, so what that means is, that's basically a times b to the x plus h plus k, and that's what we said in, let's see where we have this here. Okay, so it calls it minus h there. All right, we'll do it minus h. So we just got to remember that that's whenever you put in like a 3, positive 3 is really doing x minus 3. We just got to remember that. You can do it either way. Okay, so if that's the case, and this is how I did it when I talked about it here, right? I did do x minus 4, x minus 3. So that shows. So if I try to graph this function or draw this function, I should see an exponential shifted down 3. Looks like that's the horizontal asymptote, right? And then here I can show I have an 84 emulator here. And see that we get the same thing basically. Okay, so it is 2 times 3 raised to the x minus 4 minus 3. All right, so let's graph that with a standard viewing window. Looks the same. Okay. So yeah, I think the exponential works. And it wasn't too bad, right? We just had to do this get y method. Next, we're going to do the like a trig function, maybe, and it's going to look similar to that because it's just we got these coefficients that make some sinusoid or sinusoid function. So it's going to be similar to that.